So hopefully your board diagram looks something like this. Okay. Where are the valence electrons? Outer shell, right? How many valence electrons does it have? 3. So there's 3 valence electrons. Any other electron is called an inner electron. So shell is also used interchangeably with the word energy level. So any shell or energy level containing electrons not in the valence shell. So basically, because the valence shell is the outermost ring, everything else is inner. Got an outer and an inner. Just like belly buttons. Got an outer ear and innie. Okay, so these are electrons that are going to be important when we come to periodic trends. So inner electrons. Do you know what this is? Jack, Danny.
Is it
What?
caution?
It's not caution. Got it. Cation. Positive ion. What's an ion? It's great that I gave you a definition, but if you don't know what an ion is, it's no help. What is an ion?
An element that has a different charge and it's neutral.
Yeah, so an ion is an element or an atom oh my God. That has gained or lost electrons. So if we have a positive ion, it means it lost electrons. If you're positively charged, that means you have more protons than you do electrons. So, if boron happened to lose 3 electrons, it's got 5 protons, 2 electrons, so it would have a net charge of +3. That's where the plus and the minuses come on your periodic table. How many extra or how many you lost or how many you gained. So then, if that's a positive ion, an anion is a negative ion. And that happens when an atom or an element gains electrons. All right. Looking at your periodic table. Find strontium. Okay, Jaquel, what group is it in?
I want to say 2.
2. Second group, what period is it in? Yeah. 5. So second column, 5 rows down. Okay, strontium. Is it going to gain or lose electrons?
Gain. I mean lose, right?
I knew that's what you meant. It's going to lose electrons. all the elements that's left of the staircase, they're metals. They're all going to lose electrons. So metals are going to be cations. So what about, find for me sulfur. Find sulfur. Jack, where is it?
16th column, third period.
Okay, so 3 rows down, 16 columns over. Okay, is it going to gain or lose electrons? Is it on the left or the right? It's going to gain electrons. Okay. Okay, we're going to look at strontium and sulfur. How many electrons will strontium lose? It's going to lose 2. It's going to form a 2+ ion. Okay, so strontium will become 2+, and sulfur, it's going to be -2 because it's going to gain 2. So all your metals are going to want to dump those outer electrons. They want to get rid of your valence electrons to become more stable. You are more stable if you have an empty or a full valence shell. So metals will lose electrons to get rid of them. Because nonmetals already have more electrons, they're going to gain to make them full. So what's going to happen is, and the nonmetals want to become isoelectronic with a noble gas. Iso means same. Wants to have the same number of electrons as the noble gases. So sulfur if I say isoelectronic with a noble gas, that means same number of electrons as a noble gas. So, sulfur. Put your finger on sulfur in the periodic table. Try not to poke a hole in. Okay, it's going to gain 2 electrons, so it's going to move to the right. What noble gas is it going to be isoelectronic with? Where does your finger end up?
Argon.
Argon. So sulfide is electronic with argon. Okay, nitrogen. How many electrons does nitrogen gain? Jack?
3.
It's going to gain 3. It's 3 elements away from the last column. So which noble gas is the nitride ion isoelectronic with? neon. So when we look at nonmetals, they're going to become isoelectronic with the same noble gas on the row with them. So you just keep going to the right. Because metals lost electron, they've lost that outer shell, they become isoelectronic with the previous row's noble gas. So strontium, put your finger on strontium. It lost 2 electrons, so go back 2 elements. One element will be rubidium, 2 back will be what you think? Danny? Go backwards. Take away 2.
Krypton?
Krypton. Krypton. You go back 2. Okay? So it goes to the previous row's noble gas. So strontium 2 plus is isoelectronic with krypton. So let's look at potassium. Potassium will form a 1 plus ion because it's in the first group. Which noble gas is it isoelectronic with?
Which one?
Which one? Argon. All right, there you go. You now have some good definitions. All right. I know what else. Draw for me the Bohr-Rutherford diagram for hydrogen. So now I want a Bohr-Rutherford diagram
For hydrogen?
for hydrogen. So, how many protons do we have? 1. How many neutrons?
0.
0. There's no neutrons in this isotope. This then is hydrogen 1. This is the isotope hydrogen 1. And most of the hydrogen that exists in the universe, or at least on this planet, is hydrogen 1. We can also have hydrogen 2. Hydrogen 2. You can make it. So, what does the Bohr-Rutherford look like for this isotope? Do we have the same number of protons? Yes, because it is the same element. It is hydrogen. So, in your nucleus, you still have 1 proton. If I have 1 proton, I still have 1 electron. The mass number minus the number of protons will tell me how many neutrons I have. So in this case, we've got 1 neutron. So this is heavier than hydrogen 1. There's a third isotope. It has a mass of 3. Unintelligible. How many neutrons will it have? Jack? 2. 3 minus 1 protons gives you 2 neutrons. So these are isotopes of hydrogen. They are the same elements, they have the same number of protons. What differs is their mass because they have a different number of neutrons. Okay? Now, where do you find a proton? Camille, shopping for protons, where do you find them? In the nucleus. Where do you find the neutrons? In the nucleus. Where do you find the electrons?
In the shells.
In the shells or the rings around the nucleus. You can call it an orbit. Okay.